welcome to Desk Ladyada.
Hey everybody, and welcome to my desk. It's me, Ladyada. C'est moi desk. With me, Mr. Ladyada, also known as Senior Ada. We've got an exciting half hour-ish, 40 minutes for you here at my desk. The best unscripted live Desk of Ladyada show on the internet.
The longest running live from a desk engineering show on the internet.
Well, this week we got a couple things. We actually don't have as much hardware this week, but we have some cool documentation tools that I've been working on. Sometimes I've got the hardware itch, and sometimes I have the firmware itch and the driver itch. But this week I kind of had like a documentation itch, which I always feel like I should go, wherever the flow leads me, because usually there's a good reason for it. Like it yells in my gut a little bit.
Yeah.
Okay. Any user updates you want to give people, Mr. Ladyada? I think we're shipping Ada boxes in like a week.
Ada boxes are going to be shipping soon, so sign up if you didn't get a chance, because you may get a chance.
Check your address.
Yeah,
check your address because it's a big deal. Credit cards and addresses they add delays. We're going to take another week to ship because we have to check in with you if you have to update it.
And full speed ahead, but look at the message on our site. We have a bunch of orders, so we're managing expectations. It might take us a little bit longer because the world is turning back on, but we're also hiring people in our teams first time in a year.
Yeah.
And so we want to give our teams time to train each other up. So most of the time orders will still go out really fast, but just to manage expectation, and we have to still operate in a very safe way.
Yeah.
So it just gives us a little time. So, with that being said, back to you, Ladyada. What do you want to show this week?
Well, oh wait, do you hear that? That buzzing sound? I wonder what it is. Oh, it's our friend, the Bundlefly.
Yeah.
Hello, Bundlefly.
Chirp.
Welcome to the show. I wanted to show off, we did make a little update to the Bundlefly thanks to Justin Catney, who worked on it and been debugging it. Please, folks, try out the Bundlefly feature that we have on Learn. I'll show you how to do it right now. It should make it a lot easier to do CircuitPython projects because you get help from Bundlefly. So let's go to the computer, and let's look actually at a project that just came out. So don't forget we have this new cool random dice. You roll the dice and you get a random guide, which is super fun. But I want a particular guide. Let's look at the Lemon Keypad. So the Lemon Keypad is a project that uses CircuitPython and an RP2040 Cutie Pie to put 6 mechanical keypads in this cute 3D printed lemon. So we have a page that says like how to load CircuitPython onto your RP2040, which is cool. And then in the code, what we're doing now is we're putting code, like usually we have kind of like the code explanation and then the code itself, like the full listing at the bottom. But now we have the code at the top, and we're highlighting the word download project bundle. So when you click it, you'll automatically get a zip file, and the zip file is the name of the project. And we now include a README. And the README, the Catney wrote this up, and this is it's kind of templated a little bit. The beginning is kind of an explanation of what to do with it. And then it also includes the date and the URL that generated this. This is XEMAX, so I can't zoom in. But if you can kind of look carefully, you can see the URL and the date. So that's new. What we're going to do is we're going to go and we also have this new thing that we're going to add. I'll show you as a preview. So in addition, because some people don't realize, like, you actually have to have like the files in the root directory, and people sometimes don't realize that. So we wanted to include an image of what the file system looks like. So we have an issue for an auto screenshot maker, and this is from Foamy Guy, who's been working on this. And this is really neat. This is something that it's written in Python, and what it does is it looks at the code. Hold on, let me see. I think this went into... Oh, I think it was removed, which is cool. The generated image. Okay, sorry, it was deleted. But the goal is that it will be able to automatically create the screenshot images that we have in our guides. I was tricked because I think it was deleted. But if you look here, we have like this image that shows like the Mac file system, like with the folders opened, like the little, whatever triangle opener. And we want to auto-generate these, which we can do because if we're making the bundle, we know all the imports, we know the library, we know the files and the zip. So let's make a screenshot that automatically generates, because in Windows it's actually kind of hard to make these nice screenshots. Like Mac Finder does a very good job of showing you directories and subdirectories, but Windows like kind of doesn't have that ability. And so we're going to add the auto screenshot maker as well, so people can see a screenshot of like, here's your CircuitPy drive and here's the files that go into it. So it should make CircuitPython even easier. Like I think it's really improved by having the bundler, because especially for projects with the Funhouse, we've done a couple projects with like the Funhouse and the MagTag. There's like easily 10, 15 libraries, and it's like a real pain to dig them all out. If you use the project bundle, you'll always get the latest code, which is super cool. So that's the latest from Bundlefly, our project bundler helper. Thanks, little dude. Notice he's got the little Pi files. He's holding together.
All right, what's next?
Okay. Speaking of keyboards, I thought I'd show off this keypad that I worked on. I now have a folder in my work area called Keypad, and this is this macro pad that I'm working on. So I've been doing a lot of keyboard stuff, rotary encoders, and you've seen me have done like, I'm doing some Seesaw boards, which should be coming to the store soon, once I feel like doing hardware again. But this is a macro pad, and you can kind of see here we've got 3x4 KL sockets, so like hot swappable mechanical sockets. So it's not like a full numpad, which is 4x5. It kind of did like the math, and it's a little bit too big. It's not meant to be a number pad. It's meant to be like a macro pad. So you get 3x4 keys with a NeoPixel underneath, and then at the top here, let me show the back because it's a little easier, and then we flip it. So here we've got a rotary encoder at the top, and then this is a 128x64 OLED that kind of folds over the side. So this is like a monochrome OLED. I was also thinking of doing a TFT, but frankly, like TFTs are really hard to get right now, and they're kind of expensive. So I think I might just go with an OLED, because the prices have gone up for OLEDs, but not like 3-4 times as much as they have been for the TFT. So the rotary encoder, it's got a button, and the button is also the USB boot button, which, like with the little diode trick that we've added, is a GPIO pin, but it can also, if you hold it down during boot, it'll put the keypad into UF2 mode, because it's an RP2040. And what's really neat about the RP2040 is there's so many pins that like each switch has its own I/O. So it's like I don't have to worry about a key matrix or diodes or anything. It's just like one key per pin. And I got a little speaker also. I put a little buzzer in here. And all the analog pins, I brought out to like a header. I don't know if I'm going to do anything with them, but like, you can solder them if you want and add more stuff. And then it's got the QSPI memory and OLED. And I've got a level shifter for the NeoPixels. USB-C, reset button, and this is like the key matrix here. You can see the key matrix and the switches. So, and this will be fun because it's going to be RP2040, which in CircuitPython has HID support. We're even working on, Dan Halbert's working on some updates to CircuitPython to allow customizable USB configuration. So right now when you have a CircuitPython board, you get the REPL, which is a UART serial. You get mass storage, which is the CircuitPy disk drive. You get HID, which is a keyboard and mouse. You'll also get MIDI automatically if it's built in, like, which is for most boards that are not very tiny. And that's it. Sorry. So those four are the built-in USB implementations. But if this is a macro pad, you might not want it to show up as a disk drive. Like maybe you only want it to show up as a disk drive, like if you like flip a switch or hold down a key or something.
Like when you want to reprogram it to do something else.
Yeah, the only one, because you don't want to show up as a disk that can confuse your computer maybe. So with the customizable USB descriptors, by putting some special text into boot.py, you'll be able to turn on and off different elements. So you can turn off the MIDI if you don't need it, and you can turn off the mass storage if you don't need it. So it's only there when you want to reprogram the macro pad. So I think this will be a good demo for it.
some requests.
Yeah.
E-ink, maybe. Folks do like OLED.
Yeah, I do like ink, but I think people want faster updates, and also e-inks, they don't come in that small, adorable size. Like, this is a very specific, like 1 inch diagonal, 1.3 inch diagonal size. So there's a TFT that I use that's about that size. That's 240 by 135, and then of course the 128 by 64 OLEDs, which are kind of popular. I think OLEDs look really good, so maybe we'll try the OLED.
All right. Someone says they feel like an old person using Arduino not knowing CircuitPython. So here's what I have to say about that. It's never too late or too early to try all these different programming languages. And my suggestion is get a board when you make your next purchase that can run Arduino or MakeCode.
Almost all our boards can do
CircuitPython.
both.
Yeah.
RP2040 can do both. 7051 can do both.
And one thing that's really helpful
7021 can do both.
is find a easy project for you that you know well in, say, Arduino land, and it's like, okay, I just want to do like this pulsing light thing, and then do the same exact project with another programming language, in this case maybe CircuitPython, and do a comparison on the two, because it's definitely different. Some people really like the REPL with Python, and you can do lots of iterations, and there's no IDE, you can just use a text file, it shows up as a USB drive. But then some folks are like, no, like I'm set up for like C and like Arduino world, and they have different types of projects. But try it out and get a board. Like Circuit Playground Express is probably like one of the...
Yeah, that's a great one.
That's one of the easiest ones.
Circuit Playground Express. But also, yeah, ESP32S2 can run both. You can run also MicroPython. Try it out. You probably have an ESP32 or AT66 that can run MicroPython. Here's another spin. I made like a spin of this board. You know, I had the OLED, but I was like, what if I used a 1.3 inch TFT? Because I do have some of those still. And I saw like a really cute like ducky pad, which used a 1.3 inch square TFT. So you can see this has a TFT instead of an OLED, but it's kind of bigger. I don't know if it's like too big. So I don't know.
And for the folks, so there's folks in our chat that are working on a keyboard.
Great.
11 keys OLED. They're going to use CircuitPython, and they're looking forward to that feature where it doesn't show up as a drive. When do you think that's going to be out in the world? I mean, you can watch the progress.
You can watch the progress. I don't know. I just ordered those first PCBs, so we'll see as soon
Check out the weekly community Discord at 2 p.m. Eastern time on Mondays, and the CircuitPython team's in there, and they'll be able to tell you with the latest.
I think it's there's a PR. You can subscribe to the PR, and then it's the very latest. I will say the very latest CircuitPython is in a lot of flux right now because we're also doing a fast forward merge of all the MicroPython updates from the last few years, which is going to give us a lot of cool features that have been added to upstream MicroPython, but it just means that there's a lot of instabilities. But it also means like if you test it, that's great help to us, because if you test the latest builds, you find bugs. If people are finding bugs and you tell us, we can fix them as quickly as possible.
Yeah, that's our thing. Like some folks don't like change, but a lot of folks do like new features, and the hardware that you have just does more every time there's a CircuitPython update. So check out the updates and help us test.
Okay. All right. So next up, so the meat of the matter is I was going to talk about what I did do this weekend, which is I went outside a little bit, but I also worked on diagrams. So 4 years ago, there was this guy in the maker community who made these really beautiful diagrams, and we actually contracted him to make some diagrams for us. So if we scroll down, we can even see them. So like this feather 32U4 Proto, and these are these really beautiful diagrams that are they are PNGs, but they're like really high resolution PNGs, and they have like all these pins, and they're really cool, and they have everything labeled very nicely, and they have color coding, and they're really gorgeous. These graphical data sheets, and the person kind of had like a disastrous crowdfunding experience and sort of disappeared from the internet. So while we had paid him to do a bunch of boards while he was also doing the crowdfunding project, he kind of like left the internet. And one of the issues is that it's really hard to edit these. And so there were a couple typos. And each time there's a typo, it's like, oh my God, we have to like open this like... We have to edit the PNG if we do have the PDF somewhere, but like we don't have the original, and it's kind of a mess. And also like new boards, how are we going to make them? So Bill Binko did a video, which I think you have a screenshot of real fast.
I do.
of how you can take a template and you can make these beautiful data sheets. And it's a lot of work, but you can do it. And I think if you're only making like 1 or 2 boards, go for it. But like I make boards like every day, and so I really like this. But I also I don't feel comfortable assigning someone on the team to make these because it's like so much work. And there's like you have to look up all these things in the data sheet, and it's like the timer pin and like the ADC offset. Like there's just like so many things, and like there's so many boards, and I feel like it's just a little bit too much. So I started looking. Well, I was actually looking at this other board, this Elite C, and I was like, oh, look at this adorable diagram. And I was like, this diagram is like kind of simpler than the really beautiful Pighixxx ones, or Pighixxx. I don't know how to pronounce it. I really liked this simplified style, and I was like, I should really look into like what would it take to auto-generate these diagrams, because that's what I really need. Just sort of like what we did with the Fritzing generator. So people used to hand make all their Fritzing objects, and like I couldn't, like that's why we had like no Fritzing objects a few years ago. And then Philby spent a lot of time writing this code that we have a guide for, which lets you take EagleCAD files, the board and schematic files, and we'll like turn them into really beautiful Fritzing objects. Then you have to have a human go in and do a little bit of like cleanup just to like attach the pins and maybe like remove them or name them or whatever. But it's like 20 minutes worth of work. It's not hours worth of work. You have to do all the drawing. You just have to do like the connecting part, the part where you say like, oh, this pin is this pad, right? You just click through and connect them. So the fact that we have that Fritzing generator has been really great, because now every new product that we make at Adafruit has a Fritzing diagram, and people in the community use them to make diagrams, but we love using them because they're great for documentation, because they're really clear. It's very hard to take photos of boards. They all kind of look the same. Like they get shadows. It's like whatever. So we really like all of our Fritzing diagrams. So even if you look at this like lemon project, you can see like the diagram is done in Fritzing because we have Fritzing objects of all these items. Like somebody made a Fritzing of a Cherry MX key, and then we've got the Fritzing of the cutie pie, and it's really easy to attach all the pads and wire it together. And it's much easier to see than somebody taking a photo like this. If you took a photo of this, it would look like spaghetti. But because you can have like individual colors and it's schematic-y, diagram-y, it's kind of cool. So I like these, but yeah, I can't. This is still too much. So I looked at, so I showed you there's AT Makers did this, and there's Building as a template, and then SparkFun has the graphical data sheets, which was actually like really close. So this is like almost exactly what I want. It's like it's automatically generating all these labels, and it's doing it as an SVG, and so it's like you can scale it. You can turn an SVG into a PDF really easily. Like I don't want something that's pixelated, because it's like you can't zoom in and you can't resize it easily. It's got all the labels, and then they make this, but they have a little helper to make this part, right? This is the annoying part. The like A2 is also known as PC2, also PC in 10. This is also LED. Like that's the annoying thing. So this, the way this works, which I'm into, is it creates this SVG that has all the pins in, like it's just the pins, and then you copy and paste it over into like this part, which is like a kind of a template. You put the image of the product in the middle, and then you copy and paste them, and you just paste them in a big chunk, which is way easier than like making each little box. If you just grab the whole group. The only thing that was like I wasn't into, so the thing that I was like, ugh, because this is like pretty cool. This is like a really nice PDF, right? I kind of like this PDF, but the thing I didn't dig was that you have to create a CSV file, and the CSV file has all of the pins and ports defined. And this is the thing, again, I totally don't want to do. I do not want to make...
If you're entering a
this
CSV, you may as well
I don't want to do any
to
entry.
Illustrator because
I hate data entry.
you're in that data
And
entry world.
the thing that's killing me is the typos, right? Like people, like there's so many pins that get like swapped or like whatever. It's it's off by one, and it's very easy to make a typo. And so I want to avoid the typos. And how can you avoid typos? It's like, well, you can avoid typos by having single sources of truth. So I kind of took like all of these different ideas and was like, well, what if I had a Python script that used the Fritzing object, which is like generated from the Eagle file, right? So I know, exactly which pins are which, and also the order they're in, right? I can sort them by X and Y coordinates, and then I get the pad name, and then I can use the Arduino or CircuitPython pinout file to correlate that with the low-level I/O name, right? Because like D2 could be like IO16, right? There's this pin mapping thing going on, and then I could have one CSV for every chip, not every board, but every chip, that tells me for that chip every I/O pin what are the capabilities, and then I can auto-generate that list of pads in the correct order and still do that copy-paste thing, but like not have to do the CSV data entry, because I just don't want to do that. I'm very lazy. All right, so turns out like the nifty thing about Fritzing files, so I have a Fritzing file here. A Fritzing file is actually a zip. I don't know, people don't know that, but it's actually a zip file. And if you open the zip file, you actually get SVGs inside of it. And you also get this thing called an FPZ file. So
I always assume every file is a zip.
Pretty much, nearly everything is a zip. Seriously,
if you grew up in the world of Macs where you had like ResEdit and like every resource had something inside of it,
it's always a zip.
There's always something inside of it
People
that you can
love
explore. Yeah, so it's very similar. You just have to rename it to .zip.
So this is the Fritzing file, and it's like a mess, but it's basically XML, and you have this thing where each connector has a pin and an ID. It has the SVG ID. And then you can use that SVG ID to look into the SVG. So for example, let's look for like D2. Oops. So D24. Let's do D24. D24 has SVG ID connector 113 pin. And then if you open the SVG, which is also an XML file, like everything is XMLs and zips. If you look for connector 113? Oops, sorry. If you look for connector 113, you can see it's a circle with that ID number, and it tells you the X and Y coordinate, and so now you know where it is on the sheet. Again, that lets you sort everything in order because you want those pins to be listed in the order that they appear on the board itself, so that you have to do less work. And then you can use that this XML to find the pin name. And then if you look at, let's see, this is a Feather RP2040. If you look at the Feather RP2040 pins.c, you can also correlate the D24 to GPIO24, or like in this case, it's RX to GPIO1, right? So each pin has the pin and the underlying like GPIO, like the pretty name and then the real name. So I kind of wrote this big parser to do all this stuff, and you give it the Fritzing file, and you give it, which then unzips and extracts the SVG and the XML file. It makes a list of every connector. So it looks for the connector, like I showed you in the XML. And then it gets the SVG ID for the pad. And then it opens up the SVG also as an XML. And it finds all, like, any circle with an attribute with that same name. It also does the same for ellipses. Ellipses are weird, though, because for complicated reasons. Basically, the ellipses are sub-objects, not pins, because I use them for some connectors, and so like we have to treat them a little differently, whatever. And then For the CircuitPython file, it opens up the file and it does like a regular expressions match and just looks for the Q-stir and finds the true name. Like if I call it D2 or D24, what is the true name of it? And then finally, I do have one CSV file. And the CSV file is, I generate it, but it's not too bad because I actually kind of copy and paste it from the data sheet. So this is the data sheet for the RP2040 and it has every, sorry, where's the, hold on. I want to find IO24. This is so annoying. It's under pin descriptions. Here it is. Okay. So there's a pin table. And so the pin table tells me for every GPIO, what are the things it can do? Like it can be UART RX, it can be I2C0 SCL, it can be PWM0B, whatever. All those capabilities. And I put them into one spreadsheet. And this is every board that I have now that uses the RP2040 will use the spreadsheet as the pin mux determinator. So then it kind of puts everything together and then uses this tool called SVG Write to draw the label. And there's like, I have a little theme coloring and, you know, it makes the boxes the right width for the tech, how many characters, and then it's a monospace and it makes the box or whatever. So it makes a new SVG and it creates, it finds all the pins at the top row, all the pins at the bottom row, all the pins on the right row, pins on the left row, because you want the pins to be ordered in the right way so that when you put them in, they come apart. I'll show you what I mean. It's like you just kind of have to find out where it is on the breadboard, so it's on the breakout board. And then it draws each one. Some of them, if they're special pins, it's like, okay, this is a power pin. If it's a debug or enable pin, it's like a control pin. I have a special case for STEM QT, so that it shows up blue and yellow like the wires. And then it prints out all the different mux labels, one after the other, and then it increments the box X to draw them all, and it saves it. So I'll show you what it looks like. So this is me in the command line. So let's run it on the feather, so you can kind of see the command line here. So I'm running the parser on the feather FZPZ. I also get the feather pins.c, although I might change this to just go online and use the CircuitPython port definition. And then that CSV file, which has all the IO pins. And if I run this, it'll do all this work, and you can actually even see it kind of prints out all the pins. This D24, it says this is the SVG ID. CX and CY are the X and Y coordinates of the circle. It has alias names, and it has locations, like where is it on the board. And then what I get out is this thing called pin labels SVG. Sorry, this is the template. This is not what I get. Hold on. This is what I get. So this is what I get out. So I've got like chunks, like this is one chunk, and this chunk is the top of the board. So this is all the pins in a row, and it has the name and all the, all those, the SCL and the UART, and each one is color coded. And then this is the right side, and you can see one travels right and one travels left, because then if I take the SVG that is the image from Fritzing, and I paste it here, and then I rotate it, and then like I do like a little bit of size increasing. Hold on, this one. There you go, like that. Hold on. A little smaller. So this is like the only part I have to eventually maybe automate. Then I can take this chunk and I put it here. And then I can get rid of this. It's not too bad, right? Let me just resize this to content. Okay. You know, it's like it's not perfect, but it's pretty close. These two, it gets confused because of the fact that these are, again, they're not pins, they're like these connectors on the battery, so I have to move those. And it gets confused by the stemma QT connector too. So they're not in order. But like, it's not too bad.
Yeah, doing this live is faster than if you were to try to do this in Illustrator like everyone else.
Yeah, like I just want to do it in Illustrator, right? So this is pretty close. Like, it doesn't have it. It's not everything, but one thing that is really nice is that, again, there's only like one. Like this doesn't include the Arduino pins yet, which I have to add. So I'll have to parse like the Arduino pins file, or I don't know what I'm gonna do. Like it's not too bad that I get like regular expressions, like it's kind of always the same format. But for like all the RP2040 boards I'm gonna make, I mean, like, it only takes like a minute, and then if there's ever any typos or mistakes, I mean, like I don't think there are, because there's only one like CSV file that I'll make, and I make it against like the data sheet, and so I know it's got everything. So then I can also run.
This also probably helps some people too as they start to design boards and they want to do something like this. They can just use our scripts that we made.
Yeah. So then I can also so like I did the feather. So then if I do the itsy bitsy, which is a little bit more complicated because it has more pins, but it doesn't have a stemma QT. So in this case, if I revert this, it's now the itsy bitsy. So again, I take this, the most annoying part is I have to do the...
You're using Inkscape, right?
I'm using Inkscape, yeah. So resizing this is kind of the most annoying thing. Okay, so I've resized it, and then the only thing about Inkscape is it like sometimes freaks out and like resizes text. I gotta figure out why. This is over here, and then for this stuff, I can group it and rotate it, and then I can go like that. So that's the pinouts.
Okay, I'm gonna ask a couple questions and then we're gonna bounce through.
Yeah. We gotta go to Great Search. Okay.
Folks like it. They made some suggestions about what other file formats are. Zip files like docx, xlx, ppx, pptx. Those are all things that are
zip.
There's zip in there.
Yeah.
And then folks like it.
Yeah.
Brent's here. Brent likes it. Yep, it's Inkscape. And then how difficult it is also generate the diagrams 180 degrees and flipped over. Often I've had to hold a diagram and read it upside down due to how I have it sitting on my project.
Yeah, I mean, like, there's definitely, like, this human element that has to be done. Like, I actually looked into, like, what would it take to have it, like, put this in the right location and have all the pins. But it actually turned out it was so hard because SVG does all this, like, weird stuff with scaling and, like, and sizing and offsets. I was like, this actually isn't worth it because it only takes a minute for a human to, take those and then just align it to all the locations, especially when you're dealing with stuff like a stemma QT connector or battery connector, or like pins. Sometimes there's pins on the inside, or there's going to be like NeoPixel or whatever, like other things that need to be labeled. So I think a human has to do this final step. Okay. But it's SVG, so you can always like open it and then flip it around however you want.
All right. Can it also show PWM capable pins? I know that's usually marked on the PCB, but also in the diagram, possibly even what pins are interrupt.
Yeah, in this case, there actually aren't, like, so one of the things is we have to do is, like, the CSV is the CSV actually determines whatever's here is whatever gets shown. So for the RP2040, it doesn't have the concept of, like, interrupts because each pin is an interrupt. It does have the concept of, like, PWM. So I do have those labeled here in green. So these greens, they say the PWM pins. So whatever we put in for the board is what gets put, you know what I mean? Like, I wouldn't have I2C or like, it doesn't make, some of these things, like this chip, the way it works is like there's I2C pins available only, like, alternating kind of, it looks like every pin has I2C, but it's like I2C clock data 1, 2, and then on something like a 7021 or 51, it uses circoms, so I'd label the circoms instead, because it doesn't make sense to label I2C pins, because it's like that's not how it's done. So like each family is going to have that CSV file is going to have to be kind of custom made for that chip to show what's useful for that chip, because for 702151, every pin is an interrupt, but you want the interrupt number. Yes, we can show that. I would have that in the CSV file. So it just means the CSV file has to be customized for that use.
Okay, and someone brought up something I was about to say. So we do an Adafruit AR app. Trev heads up our iOS development. I'm going to ask Ladyada and Trevor if this would be helpful to streamline getting more of our boards into Adafruit AR. So we have an AR app. You can search for Adafruit in the Apple App Store. And we do have some ARs where when you hold up the board, it shows pins and stuff like that, but it was a manual process. This might help out with that.
Yeah, so yeah, we're just experimenting here. And there's a couple things, again, like I said, there's a couple things that have to be added that are not included here, like internal LEDs, like there's a NeoPixel. We have to somehow put that pin out somewhere, and the built-in LED. So I'm not done here, but I'm getting... This is just kind of what I messed with last night and today, and I think so far it's looking good. It's looking a lot better than what we had before, which was nothing, or these really old diagrams that were unmaintainable.
All right.
Okay.
So now let's go to a Bundlefly question, then we'll do the great search.
Okay, great.
Because we were in that section. So
yeah.
Bundlefly's back.
Hey,
And the question is it possible for me to add a Bundlefly link to the README for my MagTag project on GitHub, or at least a link for just the MagTag libraries?
Yeah, right now...
And then we also had this one, which was project-specific bundles and also board-specific bundles.
The board-specific bundles basically is we'll just have one very simple project. We don't have the ability for people to use this yet to make their own bundles. Like right now we're locking it only to the Adafruit GitHub, and it's only within Learn that's doing it.
We have this JavaScript thing that you might be able to...
However, yeah, if you look at the library bundler... the library bundle that we have, there's a JSON file in there that has all of the dependencies for every library. So you can use find imports, which is a Python tool that will search through your project and find the imports for it. And then you can use that with the JSON file for the CircuitPython library bundle to make a list of all those libraries and then extract them from the bundle. We just do a lot of caching and automation. I think...
we batch those out every night.
Yeah, Melissa made a tool that does it in JavaScript, but it's not going to do everything for you. So it's a little bit more work. Just because we had to do it, it's in Rails. It's not actually in Python, and it doesn't make sense to release that code. It's embedded into Learn.
All right, let's
okay.
Go into it. All right, so let's dive right into the great search. Ready?
Okay.
Where in the world is that part I need? The great search with DigiKey.
The great search is brought to you by DigiKey and Adafruit. Thank you so much, DigiKey. Every single Ladyada user powers for good to help you find things on the DigiKey site, and that's happening a lot because people are starting to notice there's no chips.
That's right. We have a chip shortage going on.
So here's two tweets.
These are tweets from some synth folks who are talking about how there are shortages of chips, and it's true. The 7021, there's delays on it. But also I noticed two people were chatting about how the TL074 was not available, and I was like, wow, that's pretty amazing. The TL074 is a classic chip, and it's used a lot by synthesizer folks, and I was actually kind of wondering why. So I checked in with Guest, who was the co-designer of the ZoxWox synthesizer that we worked on. And I said, you know opamps and synthesizers. What's so great about the TL074? And I want to say it because it's actually kind of neat, and it will also help us in the great search what we're going to look at. So Guest says the 074 is pretty much the Toyota Corolla of op-amps. It's not the best at anything in particular, but pretty good at everything. It's the second cheapest op-amp out there, comes in DIP and SOIC, has relatively low current consumption, low distortion, and reasonable bandwidth and slew rate. The noise is okay-ish low, but the thing that really makes it an all-out performer is the low bias current, JFET inputs. It's down in the picoamp range, which means you can use it for sample and holds or VCOs, VCFs that require range of currents down to the nanoamperes. A lot of people use the LM358 because it is the cheapest op amp, but it has high bias current. The 074 can also handle high voltage rails, which helps with the signal noise ratio. It was designed for audio use and was one of the first real mass market op amps back in the late 70s, if I recall correctly. The 741 was the first. Still people use the 741, very popular op amp. And this was meant as an improvement over that. The 074 and the 084 were made at the same time, and the 074s were selected for lower noise, better distortion, and lower offset voltage, and then marketed at the audio market. The 084 was sold to everyone else. So this is a good hint. Again, those op amps are very, very peculiar. Once you find the specs for one, it's hard to say like this is an absolute alternative, right? It's not easy to say like this is other than the exact part number. Each one has slightly different specifications, and there's so many specifications. So I will say that I don't guarantee that this is going to be a drop-in replacement for the TL074, but for synthesizer uses, it sounds like the JFET inputs in the low bias input current, and pretty good slew rate, and pretty good voltage range. So maybe more than 5 volts, like plus or minus 12 volts is pretty common for many synthesizers. So let's go to DigiKey and let's actually look up the TL074. I will say the TL074 there are some in stock. Like you're not totally out of luck if you want some. It may not be available in every particular flavor and package size, but there are some in stock. So it's not the end of the world. You can get some. But let's look at some of those specifications that Guest mentioned. So the slew rate is 13 volts per microsecond, 3 megahertz gain bandwidth product, input bias current 64 picoamperes, input offset 3 millivolts, about a milliamp and a half per channel of supply, and then plus or minus 5 volts or 10 volts to 30 volts. That is something interesting. So you do need to have a fairly high voltage. It looks like you can't really. Looks like there might be versions like here. The TL074 HIDR. There are some that can run as low as 4.5 volts single supply, but it looks like 10 volts is pretty common. So that said, let's take a look at similar op amps. It's got the JFET input. That's what kind of defines the low input bias. Let's look for another quad low input bias op amp that could be an alternative to the TL074. So let's go back to buffer amps, and let's look for active, and let's look for in stock because we're not speccing up a new board here. What we're doing is trying to find an alternative to a part that we know and love.
On a related note, so I guess for whatever reason, like 100 plus people showed up in Twitch.
Okay, hi.
And so they thought it wasn't live, and now they're being taught how to search and use electronics.
Yes.
I don't think that was their intention.
Who doesn't love synthesizers?
I think this is some type of raid or something, but you're just gonna learn. You're just gonna learn stuff.
You're gonna learn about mechanical keyboards and how to specify op amps for your own synthesizer
right, so,
modular part. Statistically, 3% of them make synthesizers or do music.
So,
you wonder, like, how are those?
Come back every Sunday and learn some electronics, folks.
Okay, welcome. Right. Okay, there's no, we're not drinking any hot tubs here, though. Okay, so we want a quad op amp because we want 074. That 4 stands for quad. 072 is dual, but we want quad. So let's apply. Okay, next step, I don't really care about the current per channel, but again, I do care about the input bias. In this case, I'm going to use this min-max box. Whoa, hold on. We're going to use the min-max box. There's actually a little bit of different styling, by the way. I think they updated the search styling. The CSS updated. So let's look. Remember the 074 was 65 picoamperes? Let's put in like 80, right? Up to from 0 to 80 picoamps. Okay, great. So we've got a whole bunch of those, and let's look at slew rate. So we want a pretty good slew rate, and some of these are like pretty slow, like less than a volt per microsecond. I think what was the 075? It was like 13 or something. Let's find something that's at least 5 5 volts per millisecond. We want per microsecond. So let's do 5 volts or greater per microsecond. And watch out, because it looks like the milliseconds are mixed in with the microseconds. Okay, great. So looking good. Got about 400 options. Okay. Next, let's look at the. We want surface mount, so let's pick that, and that'll cut us down to 300 pieces. Okay, so what else do we want to do? So the input offset. Let me look again at what the input offset was for the TL073. One thing that's nice, by the way, about op-amps is that op-amps do have, almost all op-amps have the exact same pinout, like thankfully. So if you have a quad op-amp that's in a 14 TSOP, it's going to be the same as every other op-amp in a 14 TSOP. So you don't have to worry about like, you know, it's like we talked about in some previous tutorials about, you know, oh, this reset actuator uses like a slightly different pinout depending on the package. That doesn't apply here. Okay, so the TL74, so we're looking at the slew rate 13 volts per microsecond. Gain bandwidth project of 3 megahertz is really good. Input offset about 3 millivolts, so let's do 3 millivolts or less. This is in microvolts. So it looks like, you know, there's actually like the input offset isn't too bad. There's only like one that's like half a volt. It's ridiculous. Okay. So let's take a look at what's available. So one thing about the TL074 is, of course, it's really cheap. So let's sort by price. Let's put in price at 1,000 and sort by price. Okay. So not surprisingly, the TL084 comes up first. So, you know, like Guest mentioned, if you're looking for a quick replacement for the 074, the 084 is going to be really, really, really close. It's a little bit noisier, got a little bit more distortion, but it's really close. So comparing, you know, this is 084 and 074. If we compare them, you know, the input bias is a little bit lower on this 084. The voltage offset's the same. The voltage supply is the same. You know, you can look in detail in the specs, but it's pretty much the same thing. So if let's say we're like, okay, you can't get 084s or 074s, like we're completely whatever. So the first chip that's not from that family. Another thing that's interesting is you notice both TI and ST both make TL 0708Xs. So you do have two source suppliers, which is really nice. But the next non-TL whatever series that's available is the LF347, which was like not available in TSOP, but had a pretty good specs. It has a slightly better slew rate. It has a much better input bias, 20 picoamperes. It's got 40 milliamps output per channel, which is kind of nice. A little bit better gain bandwidth product. So that basically means like, you know, as you increase your gain, the amount of bandwidth, the frequencies you can pass reduced. If you're dealing with audio, you're probably not dealing with more than like 44 kilohertz or whatever. So keep that in mind depending on how much gain you want, if you're doing microphones or whatever. It looks like the supply can be plus or minus 22 volts. Let's look in detail, maybe at the data sheet to look at the supply. All right, so high slew rate, JFET input. Again, it's got that standard quad package. Pretty simple design here. Let's look at if it has a minimum power supply. You gotta like hunt for it. Where's the... Maybe they don't have it in this data sheet. Oh, that's kind of weird. Plus or minus 12 volts. Maybe output voltage swing. I mean, I guess you could try running it at like plus or minus 6 volts. I don't think you need to. The absolute value is 18. They don't seem to really have the VCC here. Probably like 6 volts or so. It's probably the same as the 084. Okay, cool. So your options are basically find an 074 that might have not the exact same specs you want, but is close enough because there's a lot of them in the different families. If you don't mind respinning your boards, respin the board to use SOIC if that's available instead of SOP. And then, there are a couple other chips that are in a similar price range, like the LF347. If we go much farther in the pricing, there are more chips, but they start getting more expensive. Like, you're basically paying like 40 cents per chip instead of 20 cents. There's like the BU784 from Rome. So there's a couple options. So I think, you're not totally out of luck, but, like Guest said, you're going to have trouble finding something that's as cheap and as all-around good. So you might have to give up one thing, whether it's price or, noise or distortion or slew or input bias or whatever. But it's probably going to be price because, like they mentioned, it is like one of the cheapest op amps you can get. Still, there's a lot of options available. So if you're making synthesizers, do not despair. There are options available for you. Other 074s, 084s, or the LF347.
That's a great search.
Yes.
Where in the world is that part I need? The great search with DigiKey.
All right, so I'm going to do a couple questions. I'm also going to do some other stuff. So
Sure.
for the folks that are new to this, who just came in from Twitch, this last segment was kind of like a video game where you're on a quest and you have to find crystals. The part shortage is mostly because of the economies restarting and demand increasing. That was kind of unscheduled because everyone was in a holding pattern.
Yeah.
And
That's why you're hearing like it's hard to get some computer parts
Yeah.
and cars are delayed.
companies don't hold on to inventory, and
Yeah,
so
they
they're like,
don't.
"Oh, by the way, we're back. So like, can we have everything now?" And they're like,
Yeah.
It's going to be 8 weeks." Okay, next up, this is back to Bundlefly. How about using CircUp, which is already how to find bundle libs to make a project bundle? Can you do that?
Absolutely. I don't think it does, so you'll have to maybe submit a PR to add the capability. But a lot of that code came from and is based off of CircUp. The thing about CircUp was that people were just not running it from the command line. They really just wanted to download. It's like, oh, now you have to install another thing. We really wanted something that was from the learning guide. That's where people are starting with projects. They would download a zip and be ready to go.
Yeah. So, and again, just for folks who might be the first time you're watching our shows, so we have a show on Tuesday called JP's Workshop, and that's where you can build electronics and more. And then we have
Make custom keyboards. We're making keyboards
it's JP's Product Pick of the Week,
Perfect week.
which is a lot of
Sensors and Arduinos and Raspberry Pi.
If you ever want to learn to code too, this is a way to get into it with physical computing. And then Tuesday we have a 3D printing show at 11 a.m. Eastern.
Yeah.
And then 7:30 we have show and tell. People
Come
show
by with your
stuff.
projects.
And then at 8 o'clock we have Ask an Engineer. It's kind of like this show,
But you can
but
ask me.
we have a similar we have
More news.
more news, and we have similar
Updates.
segments each week. Thursday, JP's Workshop. And then Friday, we have Deep Dive with Scott. So if you're interested in electronics at all, tune into any
Come
of
on
these.
by. You're welcome.
Yeah. And,
Love to have you.
and a lot of folks that do gaming, for sure, and if you're watching from Twitch, you're probably familiar with that. A lot of people who build custom keyboards, or they'll do like cool lighting, they use our stuff. So check out our shows and more. You can
Yeah,
check
you
out our
want to make
YouTube
like
channel.
cosplay projects? We've got tons of those.
Yeah.
Decking out your PC with cool LED colors.
Yeah, so for the folks who came here with Learn with Leon, they did I guess they were doing a coding thing. Tell Leon to drop me a
nice.
note, pt@adafruit.com. I'll send him out some electronics so he can show on the show
Okay,
and
cool.
maybe give them out to some of y'all. So
Sounds great.
If y'all know Leon,
Yay.
send them my info.
Okay, cool.
Okay.
All right, thanks everybody.
That's the show for tonight. We'll see everybody next week. That was Ladyada.
Bye.